This is the concept of pod. This pod will be getting IP address, and your container will not be getting any IP address, guys. First of all, these will not be getting any IP address. Then how the communication will be happening in between these two container, which is residing inside inside the same pod, right? How they will be communicating at the time is quite easy and simple. Each of the container will be having their port number defined on it, right? Let's say for an example, this container is having port number 80, and here somehow my application contains port 80, and this container is having some port call 123 or whatever it is, like 123 port number. So if my application if my application container wants to talk to my log forwarder container, so how it will be communicating? Simply, it will be using http my pod host name will be host name will be used as pod name, okay, my pod, and then colon 123 port number. Based on this port number, it will be sending request. App container will be sending request to log forwarder port call 123, and it will be allowing it it will allow the communication at the time. Similarly, log forwarder wants to communicate to app, so on the port, based on the port, they can communicate. Clear, guys? Yes, guys, is it clear? Sachin, Habib?
Yes.
Baba?
Yeah.
Baba is not saying anything, right?
Yeah, clear, very clear.
Very clear, right? Yeah, this should be very clear actually. And this is how it works. And now let me make it something else here. This. Yes. So, I'm just writing something here like, application container. This will be my app container. How we will be deploying this container in our Kubernetes cluster, that we'll be learning, each and everything from very, very basic and scratch. Just I'm clearing the concept. I know that you might be having some curiosity, like, how we will be installing, creating the cluster, how to deploy this and that. Everything will be done here only. Just look into the concept, how things are working, because we already seen about Docker, how we created container in Docker, how we exposed it outside of the machine, right? Everything. So similarly, I'm just clearing the concept, and after this, I will be telling you the architecture of Kubernetes, and these all things will be implementing the practical. Okay, will be implementing practically. So let's see. This is one of my pod. Okay, this is one of my pod. I deployed this pod on my Kubernetes cluster, and what happens here is this pod is getting created on node number 1. Here it is getting ready. Here my pod got deployed. Now this is my application container. Now guys, I want to make it accessible outside of the cluster. Who will be telling me, like, how to expose or how to make it accessible, your application outside of the Docker server? How we used to do that in Docker? Do you remember that, guys? Docker run command, right? Detachable and --, name of your container have to define, I'm just naming it like, web01. And what else we'll be doing here? Web01 and port mapping, right? We'll have to do the port mapping so that port 8080 should be accessible outside of the machine, outside of the server, right? And finally, my image name, httpd latest. How we used to start a container, and we used to make it accessible outside of this machine by port mapping. Correct, guys? By using the port mapping. Because of this port mapping, you can access your application outside of server. But here in Kubernetes, things are changed. You have to create service. If you want to make it accessible, your application outside of the clusters, you'll have to create services. So guys, basically, we are having 3 types of services. So I will be talking about, first of all, 2 services called node port and then load. Okay, first of all, we will be talking about node port. Okay, then after that, we'll be talking about load balancer. Guys, a node port. Can you see the name? It is a combination of two words called node and the port. What it does mean, node means like IP address of the node and the port number. Kubernetes is having a few of the port range for its service called node port, which is 30,000 to 2,767. With these many ports, 2,767 ports are available for you. Guys, give me a second only. Yes, guys. So here we are having 2,767 ports are available. Let's say you want to make it accessible, this application that is running on node number one using node port service. So you'll have to create one service. Previously, things was very easy in Docker, like just write a P and 8080 host port to container port and your service used to available, right? But here things are very different. You'll have to create services. Your service will be having name like my svc something. You can name it my svc, and your service will be getting IP address 2.3.12 something like that. You will be having your service name, and services will be getting IP address. Pod will be getting IP address. Now the thing is that you have to define it, what type of service you want to create. So you can write here type : node port node port service. You can create it. That's fine, we can create it. Now the thing is that, guys, how this service will be getting to know where in which pod in which pod to route the traffic. We might be having so many pod running in our cluster. So how this service will be getting to know which is the pod where to route the traffic. So now each and every pod, whenever you'll be deploying the pod, your pods will be having label defined on them. Labels. Okay, you'll have to add the labels like app : my app. Somehow I'm just adding this label to my pod. Labels app equals to my app. I'm just defining it, right? So in the services, in your services, guys, like here, this one. So in the service section, guys, you have to define selector. Okay, selector. In the selector, what all pods to be selected, that you need to define the label app : my. Wherever or whichever pod is having this label called app equals to my app, select all of them. If you are having only one pod with this label app equals to my app, so traffic will be routed to this pod, right? If you are having a pod, multiple pod with this label app equals to my app, so what this service will be doing, it will be started doing load balancing in between those pods which is having same label assigned on them. It will be doing load balancing randomly. It will be sending it will be routing request to available pod which is having this label assigned on them, right? And now another example that I want to tell you here is, if your pod is having multiple, okay, if your pod is having multiple containers in it, okay, something DB app is running here. I want to route traffic to this pod, this container, okay, in a pod. So what we will be doing is, we'll have to define ports. We'll have to define the ports, okay, port, let's say 80. Or if you want to route traffic to DB container, so you'll have to define DB containers port. Based on the port number, traffic will be reaching to your pod's specific container. Guys, clear? Please give me a quick confirmation.
Yes.
Yes, all good.
Yes,
all good. Yeah, because once we started doing practicals, or we will be going for architecture, now there I don't want to see any confusion and all, because things will be more at that time, right? So this was our node port service. Another type of service that I'm going to discuss here now is, okay, paste it here. Yeah, I pasted it. Now see that This is a pod which is having now only one container, application container is running here, right? So now guys, let's make this IP address unique. Let's read the one. So IP will be changed, and this will be my DB container at this time. Writing here DB container, right? Guys, now the thing is that we just seen that how we can make it accessible any application outside of the cluster, correct? Outside of the cluster. Now what happened here is, this application container, application pod wants to communicate to its DB container. How this communication will be happening? Basically, this communication will be internal communication, right? Not outside. So to create this communication, to enable this communication, guys, we'll have to create another type of service called cluster IP service. We'll have to create another type of service, which is your cluster IP service. Cluster IP service. Cluster IP service is for internal communication. Getting it? Cluster IP service is for internal communication. So similar way, how we created node port service, we'll have to create one more service here. We'll have to create one more service called cluster IP service. I'm just naming it something like, let me my CSVC. I'm just cluster service. I'm just naming. Name, you can name anything actually. There is no foundation to have or to create name of your service or pod. Anything you can write. Your name also you can write there. Okay. And again, your this cluster IP service will be having one IP address assigned on it, right? 2.3 dot something, 15 somehow. 3.15 like that. Your service will be getting IP address, and again, you have to define type, service type, cluster IP. And if you are not defining any service type, so by default your service will be created as cluster IP service. Always remember that. Now, as we seen that, our labels, okay, labels should be updated here. My DB, I will be just naming it like, my DB. This pod name should be DB, my DB. Okay. This label should be my DB. So again, this service, how this service will be communicating to the pod, guys? Any clue for me? Yeah, guys. Yeah. Selector, right? Have to define your selector, label selector. Whichever pod is having this label called app equals to my DB, select that pod, correct? And based on the port, PORT, ports, you have to define here like, port number 33 or like, 3306 is a port of MySQL. That's the reason I'm writing port number 3306. So based on this containers port, it will be routing traffic to the container, getting it to your desired container. This service name, it is not, it is very, very important here. The service name is very important. The reason and the importance of this service is nothing but you can communicate with your DB pod, with your DB container from here to here, like, how it come possible? Through service name. How you will be using service name inside your application? Nothing to do, just write HTTP : host name can be used as host name. Service name can be used as host name. Getting it? My CSVC, like that. You can use it. Okay. So once you will be sending request to this service, so it will be going to here and it will be routing request to your desired database pod. Getting it? This is how this communication will be happening. And load balancer, the last type of service is load balancer service. Guys, load balancer is also used to access, to make it to make accessible your service outside of the cluster. Very, very important thing about load balancer is that load balancer can be spun up only in cloud. If you guys are using on-premise, on-prem servers, on-prem cluster, or you guys are using Oracle VirtualBox, then you'll have to install a third-party tool called MetalLB. MetalLB, that you'll have to install it on your cluster, then only you'll be able to spin up a load balancer in your local machine or on-prem machines. So this is how it works actually, how I started things, and we are diving very deeply. So yeah, now guys, most importantly, use the same API across bare metal and every cloud provider. What it does mean by API? How many of you is having idea about C programming language, guys? I'm not talking about like very deep knowledge, a basic thing, hello world program. Yeah, how you used to write a hello world program in C or C++? Yeah, guys, anybody of you did hello
Yes.
world program in C? Sachin, yes.
Yeah.
So
Right.
did you remember that? Did you remember that whenever we used to create hello world program in C++, we'll have to write first line they're called hash include stdio.h, right?
Right.
Right. What is that? Any clue? What is that?
Yeah. To include the header files where all the
Correct.
functions are defined. Yeah.
Correct. Similarly, here we are having APIs V1, V1 apps, something like that. Apps V1. We will be having these APIs. So no matter whatever cloud is your Azure cloud or Google cloud or AWS or whatever it is, APIs will be the same. Only the difference that you will be finding it out is like cluster creation method is different. But when it comes to core Kubernetes, everything will be same. Correct. So I heard somebody was talking about Openshift. I guess Habib was talking about you are working or okay, you are working with Openshift, right?
Yeah, I did a little bit of Openshift, yeah.
Yeah, I did load a bit of Openshift, right? So guys, Openshift is also based on Kubernetes. Getting it? OpenShift is also based on Kubernetes. Whatever deployment pod or things you'll be creating here, same thing you will be doing on OpenShift. But the difference is like OpenShift will be providing you one web-based dashboard where you can create deployment and all. And if you are talking about OpenShift CLI, so you will be using OC commands here: OC get pod, OC get node, OC create, like that. Here in pure Kubernetes, we will be having kubectl commands. Okay, here we will be having kubectl commands: kubectl get pod, kubectl get node, kubectl create, something like that. Rest of the thing will be same because that is based on Kubernetes, right? So things will be obviously same. My goodness, theoretical part is like it is very lengthy, and without theory, we can't do anything. As I told you, who manages Kubernetes? Kubernetes is managed by the CNCF people, again, Cloud Native Computing Foundation people that I told you already. And the key concept, atomic unit or smallest unit, and Kubernetes is called pod. Just we had discussion about it, right? Pod can be created on host. We can have multiple container. Pod will be getting IP address. You can have internal as well as external volume, right? You see, pod network, it is telling you IP address. The same thing I told you just few minutes before. And how your services will be connecting to the pods. Correct? Yeah, guys, how services are getting connected with the pods? Who will tell me? Yeah, guys, through labels, right? Here also we can see that label is defined on service app equals to nginx, environment equals to prod, and these pods will be getting label. Correct, we'll have to define labels on the pod SLC. Label app equals to nginx, environment prod. See, wherever this label is getting matched with this service, it is mapping those pods to it. See, like that. Static cluster IP, static namespace, DNS name. DNS name is nothing here. What I told you, like your service name can be like used as DNS name. Host name basically it is, and static IP address, right? Static cluster IP, it is nothing but your pods and service will be getting IP addresses. How I told you here, it is getting IP address, not this one. This is a node pod IP address, right? Pod IP and service IP. So that is nothing but this one only. Let's come back here to my another slide. It's time to see the architecture overview of Kubernetes. You know how architecture works in Kubernetes is. Let's see here. So it's basically here I'm showing you example of one master node and two worker nodes. Getting it? Master node. What is master node and what is worker node? As per the name, we can understand lot of thing. Here. And after reading the names of this node, we can have some clear picture about it. Master node and control plane, both are the alternatives actually. Master node is nothing but a manager node. A manager node who manages all the worker and all the services here. Okay, you can manage your cluster from master node. Here we can see that kubectl. What exactly this kubectl is, guys? Kubectl is nothing but a command binary. Okay, command binary file. It is a command actually that will be helping you to interact with your Kubernetes cluster. Getting it? So whenever you want to gather some information or you want to get some information about your Kubernetes deployment, how many deployments are running, so you'll have to execute command called kubectl get deployment. And whenever you want to create a pod, so you'll be executing command called kubectl create -f and your YAML file, right? Whether it is pod YAML or replication controller or whatever it is, object creation file, right? So that thing should be done through kubectl only. Here in our master node, we are seeing that one major service is running here called kube-apiserver. So guys, it is very important. It is very important service basically running on your Kubernetes master node. It is a communication gateway. Basically, all the communication will be happening through kube-apiserver only. Any component wants to talk, whether etcd or somehow plus selector, sorry, scheduler or controller manager, anything. So communication in Kubernetes will be happening through kube-apiserver only. So let's say for an example, you are executing command called kubectl get pods. I want to see what all pods are running in my Kubernetes cluster. So request will be sent to kube-apiserver. Now what this kube-apiserver will be doing over here, kube-apiserver will be authenticating the user, whether you are authenticated user of my cluster or not. Okay, that's fine. It is getting to know now, like, this request is coming from a user of the cluster only. But whether you are having permission to see this information on my cluster or not, it will be doing authentication, it will be doing authorization. If you are authorized to perform this task or perform this command, then only it will be allowing you to execute it, right? So basically kube-apiserver will be doing authentication, authorization, and it will be, once you are authorized, so it will be checking all the syntax that your command is correct or not. If command is correct, then it will be getting some information from etcd. So this is how it will work, or it works actually. What is etcd is? Etcd is nothing but it is a cluster data store. What it does mean by cluster data store, like what all, how many worker nodes is attached to my cluster, how many pods are running, how many services are running in my cluster, how many deployment secret password, such things are running in my cluster. So it is a centralized location where you can find your cluster related any of the information in etcd. As per the name of controller manager, we'll have to understand it like, controller and manager. It is controlling something and it is managing something. We are having lots of type of controller manager in Kubernetes cluster. Few of them are here, like, deployment controller manager, namespace controller manager, job controller manager, cron job, stateful sat, replica sat, node controller manager. Lot of type of controller managers are available. Each controller manager belongs to some kind of object or services. These controller manager will be making sure that respective object is working properly or not. This is the job of it, right, guys? So is it clear, guys? Yeah, clear, guys? Controller manager, they will be controlling their objects, correct? Let me go up above to the architecture diagram here. And the scheduler, as per its name of the scheduler, we should understand, or we can understand, like it is scheduling something. It is scheduling something. What it will be scheduling? Whenever you want to create pod or your pod's replica, so scheduler will be scheduling those pods in worker node. Guys, always remember that your master node will not be having application pod created in it. Application pod will not be created anyhow on master node. What is the reason that application pods are not getting created on master node? You can enable it. You can enable it. Your application pod will be started creating in your master node. You can do that, but by default, why it is disabled? The reason behind is, like, in our master node we are already having few of the services running, which is requiring more resources like etcd, API server, lot of controller managers and schedulers, right? These things will be already running on your cluster. These things required resources like memory, your RAM, right? Your CPU, your hard drive space. If application is also getting deployed in your master node, then what will happen here is those application pod will be started asking for resources. At that time, some complication might be created, like system will be thinking we are to share the resource, right? It will have to equally share the resource, your system, but because of your application container, your component on deployed on master node, they will not be able to perform well. That is the reason Kubernetes says that do not create your application pod on master node, but still you want to do that, you can do that as well. You can enable it, right? By doing some setting, we can enable it. Now, worker node, few of the component on worker node that we can see here is kubelet. What is this kubelet? Guys, kubelet is nothing but it is a daemon. It is a service running on each and every node, whether it is master or worker. Everywhere kubelet, you can find it out. The job of kubelet is to create the pod, create the containers, right? Manage them. All those things will be done through kubelet only. Here we are seeing one word called container runtime. What is container runtime? So guys, container runtime is nothing but your Docker only. Why these guys are not writing their Docker directly? Instead of Docker, they are writing container runtime. The reason behind is Docker is not alone in market. The competitor of Docker are a lot of competitors of Dockers are available in market. First one is called Podman. Podman is also competing to the Docker. Podman is a product of Red Hat. Kubernetes supports Red Hat, a product called Podman. It supports Podman, Watlat, Kata, CoreOS, different type of containerization tool it supports. So that is the reason they are not defining the name of any the tool like Docker. They are simply writing container runtime. For different container runtime we can use here in Kubernetes, but we will be going with Docker only, right? So let's see the things in flow. Here we can see that your outsiders or your end users will be accessing your application through load balancer, or if they can access your application through node port service. These requests will be landing to one service running here in your Kubernetes cluster called kube-proxy. Yeah, that thing is missed. Okay, request will be hitting to kube-proxy. Kube-proxy will be sending a request to available pod, whichever is should be accessible. So it will be routing request to that application pod. On all this request will be routing through services only. Getting it? So that is it. And let's see a complete flow how things works. Let's say I want to create one deployment with 3 replica. Okay, here what I told you, did you remember that one thing I told you here, if you are saying that 3 replica of my application should be up and running in my cluster, so that application 1, application 2, right? I was saying that 3 replicas should be up and running, correct? So what I told you, Kubernetes will be making sure that 3 replicas are running on your cluster node. But which is that object that will be helping you to create 3 replica? There are few, okay, that I will be discussing in today's session. Which one is first? First is replica replication controller. First one is replication controller. Second one is replica set. Third one is
Hello everyone, if you would like to access the remaining videos of this playlist of 50 plus more tools which are coming under DevOps, DevSecOps, SRE, DataOps, GitOps, etc. Kindly become our channel members by clicking on the joining button. You would have access to 100s of playlists and 1000s of videos lifetime access with this membership. Enjoy.
Thanks for watching. Want to study further? Join our training programs today.